The question says, the graph of a function y equals little f of x is shown. Make a sketch of the antiderivative big F, given that big F is continuous and f of 0, big F of 0 equals 3. I've already drawn that here. That's what this red dot is right there. That's big F of 0 is at 3. It tells us that. And because f of x, little f of x, is what's shown, and big F is what you're looking for, that means little f of x is the derivative of big F of x. It's big F prime x. And you know, over a certain range, f of b minus f of a, big F of b minus big F of a, equals the integral of a to b of f prime x, big F prime x dx. And that's what it means. F prime x, we find the antiderivative, and that will give us big F of x. Okay. So let's see if we can figure this thing out. And that also means something else. It means that the change at the end of each range is going to be the area under or over the x-axis. If it's above the x-axis, the change is positive. If it's below the x-axis, the change is negative. So let's look at our first change. I'll do these in blue. I'm going to write the graph in red. The change is constant. It keeps going up 1. Every time x increases by 1, y increases by 1. And what's the total change? It's going to be the area above the x-axis. It's positive. 2 times 1 is 2. So it's going to go up 2. From the time we get from x equals 0 to x equals 2, it goes up 2. So it's going to go up to 5. And you can just connect those with a line now because the change is constant. It's a constant slope of 1. Little f of x is the derivative, which is the slope. But I'm going to draw the interim values. When it goes from x from 1 to 2, it goes up 1, so it's here. And then x to 2, from 2 to 3, it goes up 1. And we'll connect those with a line. So I just drew the points in, and wait a minute, maybe my points aren't exact. So I'll do the best I can. All right, that's what it looks like from 0 to 2. Now, from 2 to 5, the slope is negative, and it's -3. It's a constant -3. So again, it's a linear equation. And the total change, we can just draw the endpoint here, is 3 times 3, which is 9. And again, it's negative. I'm not going to put -9 under because that may get confusing. It's 9 under the x-axis, which means 9 down. So we're at 5. 9 down from 5 is -4. So by the time you get to x equals 5, the graph is way down here at -4. And again, you could connect those with a line. I'm going to go, every time I go up, I increase x by 1. I go to the next x. I go down 3. 1, 2, 3. So that's at x of 3. And then at 4, I should go down 1, 2, 3. I'm at -1. And then at 5, it's at -4. So connect those with a line. You don't have to draw those interim points if you don't want to. I wanted to, and then I connect them. And then from 5 to 7, the slope is +2. So every time x increases, the graph increases by 2. And you can draw the endpoint. 2 times 2 is 4. So that's how much it increases, 4, the area. And it's above the x-axis, so it's positive this time. So it increases by 4. And from -4, increased by 4, it's going to end up at 0. And again, you can connect those with a line now because the slope is constant. It's a constant 2. I'm going to draw the interim points. When I go from 5 to 6, I go from -4, and I go 1, 2 up. So at 5, it's at -2, and it's at 6. At 6, rather, it's at -2, and at 7, it's at 0. But you can just connect them with a line like that. And there is your graph. In red is the graph of big F of x. Hold on, I didn't have the pencil selected. Big F of x is this line. And again, big F of x is the antiderivative of little f of x, which makes little f of x equal to big F prime of x. And with the information they gave us, we have now graphed this function, big F of x. Got it. Thank you.